Good morning. Pleasure to be here, and certainly following a talk like that, it's a very clear, very solid, a very good presentation. I'm going to kind of change the pace just a little bit here, and I don't have a system specifically to talk about here. I'm going to kind of talk about things as a whole and some of the challenges that we have seen with moving things from research environments into more practice environments. And this is not intended to specifically target any particular effort, but more sort of talk about the field, the state of the field a little bit in general. And so I'm going to talk a little bit about data-driven security challenges. And specifically, I'm going to talk about, after a brief introduction, giving some motivation, I'll talk about a list of challenges that we've seen that are involved in moving things into more production. And certainly a lot of this is an amalgam of some of the things that we've heard in discussions, both at past FloCons and with people that are trying to do network operation centers and particularly use advanced methods in network operation centers around the country. We're going to talk, one of the big challenges is data, and so we'll focus specifically on what are the characteristics of the data that we'd really like to see in order to demonstrate utility, in order to provide a stable basis, and then what are the what's involved in getting that data, and what are the barriers to getting that data. And then closing with a brief summary. So what do I mean? Data-driven. I mean, we're interested in looking at things which are supported by live capture from computers and from computer networks. It's supported by does not necessarily mean directly used. It may be that what you're doing is doing measurement of live network traffic and then using that live network traffic, those measurements to derive synthesis of them or production in there. But it's some way in which you're making use of what is real, what is live, in a measurable manner to really move things forward. So we're not talking about what are the theoretical basis based on decidability theory. We're talking really more brass tacks, how do we get things which are actually more or less real. In terms of security, I picked the standard security definition, the CIA triad, applied both to networks, to hosts, and to data. And then challenges, well, these are the issues and the conflicts that occur in moving from research into practice. So moving things forward on there. And the motivation we have comes from, again, experience in evaluating methods for network security, particularly methods that will scale to and above the level of a network security provider. So we're talking broad scale network security, which is an ongoing theme at FloCon. And then we talk about our desire to provide methods that are used in realistic security defense, ideally in real security defense of networks, and that's certainly a concern many of you have shared in discussions already at the conference. And we also have an inclination for security methods that don't just apply to a single context or a single portion of the industry, but rather have some degree of generality across industry sectors, across networks, and also apply to a broad-scale series of attacks. So we're not looking at things which deal with one particular worm, virus, or botnet, but instead it can apply with some degree of generality. And the challenges we face. One is, to put it mildly, we need to have a capability where somebody other than the developer can make use of the methods. And that tends to fall down on the question of reproducibility. We'll also talk directly about what are the challenges in scaling things up to the ISP level and above. As was pointed out in the data science talks yesterday, a good portion of what gets done in analysis is handling unclean data, and so we'll talk about that. We'll talk about applicability to evolving threats and adaptability to encrypted traffic, because we are in a field where The attacks that we really were concerned about back in 2008 when we were here at Savannah before really are not the attacks that we're worrying about today. It's done. And the attacks that we see when we are fortunate enough to visit Savannah again, which probably won't be next year, are going to be new attacks yet again. So we need to deal with the fact that the threats we're concerned about, the attacks that we expect to see are going to change, and deal with that. And at the same time, while we are looking at monitoring and analyzing network behavior, privacy concerns are driving the fact that more and more of that network behavior is in fact encrypted. And we need to be able to develop methods that deal with that fact, that endpoint solutions such as the one we just heard are going to become more and more attractive simply because the network connections are going to be largely concentrated on a few ports and a few protocols due to the increasing need to support privacy via VPNs and SSL and things like that. TLS, pardon me, I'm showing my age. Okay, reproducibility. We want methods that can be reconstructed in an evaluation or usage environment, duplicating results from the development environment. So in the short, that's a lot of words for saying we want methods that can be used by someone other than the person that created them. And that means they need to be described in sufficient detail. Well, what's sufficient? You got to answer questions like, okay, functionally, what is the method? How does it work step by step? Can we lay it out in a way where the steps are clear using known nomenclature, using known concepts, step by step, and saying we've got that laid out? But nobody develops in a vacuum. We need to be able to say what related work is essential for making use of this, what libraries, what other systems, and as we just heard, the system monitoring solution that they used was a good example for those that, provides a clear link of, okay, you develop this package and then this is add-on to it. And here's basically the way it laid out. It's good for a conference presentation. When it actually comes to deploying it, there's going to be some wrinkles. There's going to be some specific features, and identifying those in a sufficiently detailed way where somebody other than IBM Research can come in and employ that solution is always a challenge, and is always an ongoing challenge. And I'm not specifically singled them out. It's everybody who's deployed a system has dealt with that and trying to deal with those things of having an analytic that works by someone other than the analytic author is always kind of a challenge. You want to identify all the necessary parameters for constructing or adapting it into a different environment. And that's often difficult because as we develop solutions, we're developing them for the environment that we know. And as we're exporting it out there, it's going to be used in environments that we don't know. And being able to parameterize things so that we get a degree of generality. We want to be able to say, okay, what constitutes a similar environment? What's the assumed knowledge about, are we dealing with a endpoint network? Are we dealing with a transit network? Are we dealing with a network that basically works 9 to 5 within a given time zone? Or are we talking about a network that's deployed worldwide and it's 24/7? Are we dealing with a network that contains specific pools that are of interest to a group of attackers? What kinds of defenses are we going to assume are present? What kinds of other monitoring packages and other environments are going to be there? And all of this needs to be presented in a clear enough way that comparison is feasible. That we describe with a degree of precision what's involved, that any particular transformations of data, summarizations or data format shifts are also clearly laid out. And a lot of those things tend to get swept under the rug of, yeah, we know we can plug A into B, but the mechanics of doing the translation necessary for this work are often problematic. In terms of scalability, you want to be able to provide a sufficient level of detail for the level of use that is envisioned. Having a system that gives clear and concise results for a local network solution is a very different thing from one that works for a broad network solution, and is different yet again for a super enterprise solution, where you're dealing with things at or above the ISP level. You get confusing results as the scale increases. The amount of detail present becomes in and of itself a basis of obfuscation. Your data displays often grow too crowded to be able to do that. The plot goes gray as all of the links populate. You end up with axes of variation that are not initially considered, as you have different types of hosts, different types of gateways that blur some of the network detail that's present. You also get response times issues, and this is simply a matter of analytic performance. An analytic that works quite well in a small and restricted environment and gives very timely results may be massively inefficient when applied in a broad scale network. And that isn't necessarily a critique of the work, it's just an issue and a challenge that you face as you transition and as you start looking at things at broader scale. Even assuring the presence of the data that's needed for a particular analysis can become an issue, because you run into the issue of how much can we afford to backhaul to an analysis location? How much must we process on the local node and retain on the local node, because otherwise you're going to just chew up too much network bandwidth for your network monitoring solution. Then you get into the issues of, okay, if we're going to federate data sources and we're going to have these things stored all locally, how do we make sure that the data sources are present, available, and coordinated across the systems? Finally, how do we make sure that we know where the data is actually coming from? As we aggregate, as we transform, as we scale things up across federated solutions, is this host level data? Is this network-based data? Is this user inventory-based data? Often some of that information, as we enrich data, the provenance gets blurry. It gets lost. This is popularly known in this field as the data goes brown, because as you mix colors, as we all know, the brown tends to be the result of the color, and it becomes literally clear as mud as where the data actually came from. And trying to deal with that often is a scalability issue, to try and understand what is authentic and where that authentic data actually came from. It's also the fact that network attackers really don't produce clean data. And I know this is a surprise to precisely no one in the room, but the attackers really don't want us to be able to find out who's attacking us and what their intent are. It's also true the network defenders aren't necessarily interested in producing clean data. They want private data, they want tracking data, those kinds of things, but there tend to be traffic artifacts as network services are employed with things like exponential backoff, repeated termination. In the case of attackers, they do scanning and sometimes exploit background scanning behaviors rather than doing their own targeted scanning, or they'll engage in distracting attacks to try and deal with those. There's a lot of deception applied at the attacking level and some deception at the network defense level for hiding and concealing things of privacy, and that makes the network traffic analyst's job harder. That makes the task of us to get a consistent state on which we can make security decisions much more difficult. The data is almost never normally distributed, to the point where when we discover something normally distributed, it's actually an event. Wow, we got something that actually matches a reasonable statistical distribution. Power law curves are very, very common, but not terribly revealing. A lot of network behaviors are driven by work cycle and by network stacks, not by the individuals that are involved. And attack behaviors, frequently they're interested in exploiting attacks which are down in the noise. Rare events among rare events, such that it becomes difficult to assess those kinds of things. We often need to transform our data before it can be effectively used or displayed. We need to regularize the data. We need to clean it. We may need to scale the data such that things that are among the noise become a little bit more visible. We may need to apply secondary measures to the data to determine how and determine whether or not behavior is actually present at all across the network. And that process of cleaning data is a major part of the analysis task, but a part that is often omitted in the descriptions that you read. They present the clean plots. They don't necessarily go through the work that was involved in actually getting to the clean plots. Security is also facing some unique challenges in the field of computer science and really in the field of engineering, in that we face a motivated, intelligent, and resourced set of attackers. What does that basically mean? Motivated. They aren't going to stop. We aren't going to be able to present a defense which is creditable enough to where they will run away screaming, saying, "Oh no, it's defended." They're too, our win isn't necessarily their lose, and they are adaptable enough in their goals to where they're quite willing for our networks to continue running while they exploit us. They're quite willing for us to continue to use the network and put data on it while they observe that data and leak that data. Intelligence, they're quite willing to consider what our assumptions are and to exploit those assumptions to provide their opportunities. Resource, they can afford some expensive options. Getting more hardware, getting more things. These are not hobbyists working in their basement. These are not isolated individuals working across there. Very often these are, they've learned how to support themselves. They've learned how to generate revenue. And they've learned how to make investments that help assure their revenue stream. And so we're dealing with the fact that the type of assumptions that we made in the past aren't necessarily valid today. Our networks attackers have been shown to statistically shift activity in a small number of days. So this evolution that we're talking about is not slow evolution. They anticipate defenses, they adapt to defenses, and our concern as network traffic is to be able to spot that shift of behavior, to spot their adaptations, and to inform defenders as to what those adaptations are and how to overcome them. So the new attack options, the new vulnerabilities, the defeat of countermeasures, those are active goals that we need to have as we deploy our network metrics. And as I mentioned before, this is occurring in an environment in which there is increasing use of encrypted data. On production networks, peak levels of use go up to like 50% of all traffic being encrypted. Of that, the vast bulk, more than 90%, is on one port, TCP 443, okay, which is a surprise to no one. That's encrypted web traffic using TLS. HTTPS is the vast bulk of this. The most common chunk beyond this is TLS on non-SSL ports, but there's significant amounts of VPN traffic as organizations support virtual private networks, and SSH traffic as they support point-to-point communication and tunneling for dealing with that. This fraction of encrypted traffic is still increasing. The most recent data we have indicates increasing linearly. It's increasing at about 3 to 7% a year. And I leave it to the network defenders in the room. How long can we tolerate this increasing blind spot? And yet, this is the point at which web exploits and code insertions and email and webmail stuff are really where the attackers are meaning to focus their attack. They're focusing their attack on things that we literally cannot see at the network level because it's all hidden within encrypted connections. But our solutions are both limited and unattractive. Okay? there is the natural approach of saying, great, just don't do that. Forget about encryption as a network traffic thing. And that's an unworkable solution. If we made any statement like that, it would simply be ignored. Okay? The second approach is to proxy it. And that is you break security to enhance security. And as the Department of Homeland Security recently documented, doing that just simply shifts the target. You're creating golden, favorable targets that strike and deal with that. Or you use content agnostic or content inferential methods at the network layer. But the problem is if you ignore the content or you ignore the port behavior, you're going to get some more increased blind spots. We're gaining more uncertainty in there. The plus side of this is not a new problem. Dealing with encrypted connections and interpreting encrypted connections has a very long-standing history, just not on computer networks. It's been part of communications privacy for a long period of time, and exploiting some of the existing methods for dealing with communications privacy in the face of encryption are methods that are known. We just simply have not exploited them effectively yet. And so there may be some solutions out there that would be much more adaptive and effective out there. The problem is it's very difficult to get good data. It's very difficult to get good data that we can actually use and publish. This is because what we'd really like for good data is real data. Capture somebody's network traffic, use it to develop our analytics, have established standard data sets that are applicable to real networks. But the problem is a lot of real traffic contains data that is just simply too sensitive. You've got personally identifying information, or academic records, or protected health information, financial access information, all of which is legally controlled in a lot of jurisdictions. The European privacy concerns for the folks here in private are real and true. Even for domestic individuals, these privacy concerns are very effective and concerned. There are non-disclosure and publication review requirements. There are human subjects requirements that apply for considering reputation, and dealing with the more recent human subjects concerns very much limits what researchers can ethically do. And provably transforming the data to protect the information. There are techniques that have been proposed, even proposed here in prior conferences of FloCon, but those methods are also unfortunately defeatable. The more you know about the data set, the more use you make out of the data set, the more inferences you can draw that defeats the removal of protected information. We also want to have a realistic mix of what kind of traffic is there, and there are a number of different aspects that we can do that on. The trick is we want to make sure that we've got attacks which are neither over-present with malicious behavior nor so benign that things are in place. So in summary, and my session chair has been generous with giving me a little bit extra time, what we really want is we want to be able to find or develop or share advanced methods that actually work, that are actually described well enough, general enough, and effective enough that this can be done. We want to be able to support development, to support training, support evaluation, using data sets that realistically represent real networks of scale. And I know of no data set that applies that in the current time. There are a lot of data sets which are built off of exercise data. There are a few data sets which are built off of generated data, but none of them, all of them fail one aspect or another of realistically representing data. And we want to be able to have methods that find the threat where it is, not where we would hope it would be, or not where it's convenient to look for. And I notice a lot of nodding heads around the room, but I'm certainly willing to answer your questions should you have them.
is it off? No, I think it's on.
Yeah. You're on.
Yeah. So that was a very gloomy talk. It seems like there's lots of problems and no solutions. But the one interesting comment, I just had a comment I wanted to make, and that was when you go over the challenges, like many of them involve presentation, and I thought that was interesting because it's not just writing an analytic, it's also how do you present the results, and I thought that was interesting. That showed up multiple times in multiple different contexts. I thought that was interesting.
Thank you.
First, thanks for filling in for the Mothra talk with 3 weeks notice. We appreciate it while we get our approvals in order, so thank you. When you're talking about the encryption, when we know that it's an encrypted set of traffic with either something specific underneath, how would you like to see that presented in flow? As in, is this a SSL flow or an HTTP flow with noted that it's encrypted?
I'm not sure you can do that at the protocol level, at the network layer. I think you need to somehow provide robust mappings of encryption into intent, and that's a mix of aggregating several flows and understanding what the patterns are, the larger scale patterns that are exhibited, what context is present, or also paying attention to the endpoints and what are the categories of the endpoints. Is this a normal communications partner? Is this an abnormal communications partner? Is it one in which we have some reason to believe it's a threat? Or it's a third-party site that really has very few controls and protections built onto it. And those are the types of things that we can still answer despite encryption. And that may lead us to focus on digging deeper using systems like the folks from IBM just gave.
Nice. Thanks, Tim.
But short answer, I don't think it's a data structure issue.
Good to see you, Tim.
Good to see you, Carter.
So what scale? How big? How many end systems do you want? Because you work for an organization that gets lots of money, like from DHS, and DHS has a massive network itself.
Right.
So
and
you
protects a larger network, yeah.
You have many sponsors that could provide you with operational data that's one day old if you were looking for it. But I find it dubious that academics always seem to think that getting the data is hard. I think you can make your own data at Carnegie Mellon and have massive amounts of data. Don't you think? Well, so how much data are you looking for? What kind of scale are you looking for?
Okay, first of all, having the data is one thing.
Mm-hmm.
Sharing the data or discussing the data with any degree of fidelity is quite a different subject. There are organizations that are willing to let us look at their network data, protected by NDAs a mile thick.
Well, this whole thing about anonymization and all that kind of stuff has been with us for 20, 30 some years.
It has.
So we're not going to solve that this week. So, but how big do you want? How much data? Do you want 1 million end systems? Do you want 10,000 end systems? Do you want 5,000 end systems?
Well, if I'm looking at things at the ISP level, then probably 10,000 would be a lower limit.
So Comcast has a great little network infrastructure now that they're generating a lot of data. That's pretty good. So you could get about 20 million from them. But we have to put together a reason for us to have that data, right? You have to make a compelling argument to industry to actually make the data available, right? But I've never seen anybody make that case.
But as soon as the data contains legally protected information.
Oh, we can figure, that's not hard to solve. So, I mean, Argus, for instance, I wrote Argus a long time ago, so Argus is one of the competing technologies. So we've had anonymization Argus for 20 years, and it's really good. Nobody's broken it, it looks really good. Nobody's complained about it. So, and it does things like address hierarchical preservation and all that kind of stuff, for addresses, and that's the big deal. And content, NetFlow never collected content ever, so we didn't have to really worry about that, right? So I think the anonymization is an interesting game, right? I think you can solve that problem.
At the NetFlow level, you probably can.
So
at
when you start
level,
adding content and things like that, I think there are other things you can do, and it's worked pretty well for a lot of organizations like DHS, So I'm very sensitive and very appreciative of the notion that we have to solve some of these fundamental problems. There's no question about it. But for 25 years, it's always been we can't get the data and we can't share it. but we've been doing that within organizations for a long time, right? So I think we can get past that pretty quick and start getting into some of the more important things, like should I be able to extract certificates on SSH calls? Is that private information? But it
Might
gives
be.
away the original identifier and the actual, identifying information. But should you be able to extract certificates on SSH connections? To me, that's the real important sort of issue, is how far do you have to go with encrypted traffic before you actually get any utility out of it. Do you have some opinions about that? I know you do, but I'd love to hear what you say about
I have opinions, but
extracting
I'd
that
rather
kind of
explore them offline.
Okay. Well, it's good to see you, Tim.
Good to see you.
Thank you for capturing a lot of things that have been going around in my head for years. And a couple comments on that. One addressing the points that were just raised, that I think the ground truth in real data is something that is not addressed enough, that especially, a lot of private enterprises, it's very easy to go off, IBM research here, just picking on you because you just talked. Very easy for them to go off and get IBM data and just work on that internally. They might not be able to share it with other researchers, but at least they can say, hey, you can go off in your own organization, collect all this data. But the fact is we don't have ground truth on it. And I go into these large enterprise networks, I look at the real network data, and I'll be darned if a very significant percentage I look at and I'm like, I honestly can't tell you if this is benign or malicious. It's just odd.
Yeah.
And so that's one point. The other on reproducibility, you mentioned it in the voice track, but I think it'd be great to capture on the slide the capturing of assumptions. And this goes to the previous comment as well in terms of the presentation, that oftentimes researchers presenting this information, a lot of it that I fail to see in the papers, in the conference tracks, is really documenting what the researchers are assuming about the environment. Some of it, dealing with flow information, they just go in there and there's this unwritten assumption of, oh, we're dealing with net flow. But I come in here and I'm using bro flows or Argus flows or whatever, and the results are going to be different just because the collection mechanism is different. And that's true at all various levels, that I definitely like to see better work done on the documenting of assumptions of the environment that the researchers are using. So thank you, Tim.
My pleasure.